when we discuss motion, we often talk about energy. Okay, and here are the most common types of energies we talk about. First, I'm starting with the gravitational potential energy. Gravitational potential energy is involved whenever there is a change in height. Whenever there is a change in height, going up or down, gravitational potential energy is involved. It is directly related to both the mass and the height. So an object gains gravitational potential energy when it gains height. It loses gravitational potential energy when it loses height. It loses gravitational potential energy, it loses mass as it loses mass. For example, an airplane that is flying up in the atmosphere, as it is burning fuel, it is losing gravitational potential energy. Now, elastic potential energy is involved whenever an elastic material, a material that is capable of regaining its shape, like a spring, something, that's what we mean by elastic material, is compressed or stretched. So elastic potential energy is involved whenever an elastic material is either compressed or stretched. Having an elastic material is not sufficient. It needs to be compressed or stretched for elastic potential energy to be involved. Again, elastic materials can be like a spring, a rubber band, a bow in a bow and arrow, anything that you can change the shape, and then when you let it go, it's going to try to regain back its shape. That would be an elastic material. Now, elastic potential energy is directly related to the stiffness of the elastic material and to how much it is either stretched or compressed from its equilibrium length. So it's going to be related on the kind of material itself. And then how much do you stretch it or compress it? An object gains elastic potential energy when it is either compressed or stretched. It loses that elastic potential energy when it is being relaxed to its equilibrium shape. Now, the other type of energy is electrical potential energy. It is involved whenever we have charges that are separated by a distance. It is directly related to the charges and inversely related to the distance separating them. It increases when the charges increase, and it decreases when the separation between the charges increase. Now, elastic potential energy electrical potential energy is not talked about often in this level course. Electrical energy is the energy used when running most of our electrical appliances. That's electrical energy. Electromagnetic energy is the energy carried by electromagnetic waves. It is directly related to the frequency of the wave, which is equivalent to saying that it is inversely related to the wavelength of the wave. The higher the frequency, the more energy that wave is carrying. The shorter the wavelength, the more energy that wave is carrying. Electromagnetic energy is also related to the amplitude of the wave. For example, if we have two X-rays, the X-ray with a higher amplitude is carrying more energy than the one with a lower amplitude. Other forms of energy, chemical potential energy. It is involved whenever there are chemical bonds between elements. Chemical potential energy is released whenever the bonds are broken. Energy is needed to form new chemical bonds. That's the relationship between chemical potential energy. Remember, chemical potential energy is involved whenever we consume food. Because what's food? It's matter that's held together by bonds, by chemical bonds. So when we consume it, we break those bonds. So we take the chemical potential energy that is in the food and transform it into other chemical energy in our human cells. Chemical potential energy is transformed into thermal energy whenever we burn an object, for example, fuel. All of our human physical actions are facilitated by chemical potential energy in our cells, being transformed into kinetic energy. Sugar in our cells is used as the fuel that will allow us to move our hands, legs, producing kinetic energy in the process. The word kinetic energy means the energy associated with motion. It comes from Greek. It's dealing with motion. So whenever an object is moving, kinetic energy comes into play. It is the energy of motion. Whenever friction is present, heat is generated. Remember, when you rub your hands against each other, they warm up. So whenever friction is present, heat is generated. Whenever heat is generated, some type of energy, for example, chemical energy or kinetic energy, like if something is rubbing against something, is going to turn into thermal energy. Whenever heat is generated, some type of energy turns into thermal energy. Now, let's talk of thermal energy. Thermal energy is involved whenever there is heat. At a molecular level, thermal energy is the total amount of kinetic energy of all molecules in a substance. It is the total amount of kinetic energy of all molecules in a substance. So, motion of the molecules making up a substance, motion, their kinetic energy, translates into the thermal energy stored in that substance. Okay. Temperature is also related to the kinetic energy at the molecular level, but it's related to it differently. While thermal energy is the total amount of kinetic energy, temperature is related to the average kinetic energy at the molecular level.